Let's kick things off with one of the biggest questions in cloud security. Who, or maybe even what, can actually get to your most critical data? It's time we found out how to get a real, solid answer.
I mean, really think about that for a second. Inside your AWS environment, right now, do you know with 100% certainty who has access to your most important S3 buckets, your databases, or your encryption keys?
Because, let's be real, in any cloud environment that's been around for a while, permissions get messy. And they get messy fast. Over time, all those policies can turn into this tangled web of users and roles and services, making it almost impossible to have a clear, confident answer. And you know what? That uncertainty is a huge security risk.
So here's our game plan for this explainer. We're going to break it all down. We'll start by digging into the core problem, then we'll meet the tool built to solve it. After that, we'll walk through its most powerful features, from sniffing out external threats to actually building safer policies for you.
All right, let's start with the problem itself. I want you to picture your cloud environment as this enormous building with thousands and thousands of doors. Some doors lead to sensitive customer data, others control powerful systems. Now, what if you had thousands of keys, but a whole bunch of them weren't labeled, and you had no idea who had copies? Well, that, my friends, is permission sprawl.
Right? Every single time a new developer joins your team or a new application gets deployed, you're basically handing out another key. Over months and then years, this just creates a massive and often totally invisible attack surface. An old, forgotten permission is literally like a key left under the doormat, just sitting there, waiting for someone to find it.
Okay, so this is where our digital detective enters the scene. To cut through all that complexity, AWS built a very specific tool designed to give you those clear, definitive answers about who can access what. And it's called IAM Access Analyzer.
Now, the key thing to understand here is that this isn't just some simple scanner. No. It uses something called formal reasoning, which is a fancy way of saying it uses mathematical logic to explore every single possible access path that your policies create. It's not just looking for obvious typos. Its job is to prove, with mathematical certainty, whether or not an unintended access path even exists.
And here's the magic under the hood. It's all powered by an engine called Zelkova. The best way to think about Zelkova is as an expert translator. It takes those really complex, sometimes confusing IAM policies, and it converts them into these precise logical statements. Then it uses a solver to give you a simple, provable yes or no answer to the question, can an outsider access this thing?
And this comparison just says it all, doesn't it? The old way was slogging through these slow, manual audits that were, only a snapshot in time and so prone to human error. Access Analyzer just completely changes the game. It's automated, it's continuous, and it's built from the ground up to handle the crazy scale of a modern cloud environment.
So let's dive into its first major job, figuring out who from outside your organization has the key to one of your doors. This is almost always the #1 risk you need to get a handle on.
So how does it do this? Well, it starts by defining what's called a zone of trust, which is basically your AWS account or maybe your whole AWS organization. Then it's constantly scanning the policies on your most critical resources. We're talking S3 buckets, KMS keys, Lambda functions, and it's on the lookout for any policy that grants access to what's called a principal. That's just AWS speak for a user, a role, or another account that's outside of your zone of trust.
And when it spots something, it generates what's called a finding. Think of this as a super clear, actionable alert. You can see here it tells you exactly which resource is exposed, what kind of exposure it is, like public access to that critical S3 bucket, and it helps you prioritize what to fix first. This isn't just noise, it's a clear signal to go take action.
Okay, so we've checked the perimeter. The next job for our digital detective is to clean up the mess inside the house. This is all about enforcing that golden rule of security. The principle of least privilege, making sure people and programs only have the permissions they absolutely need to do their job and nothing more.
And that internal mess can be pretty significant. We just collect permissions over time, it's natural. This chart here shows a pretty typical breakdown of what Access Analyzer finds. Entire roles that haven't been used in ages, specific permissions on active roles that are never actually used, and old risky credentials like access keys that are just collecting dust.
So, and this is the crucial part, it gets really specific. It doesn't just tell you a role is active. It looks inside that active role and tells you which permissions haven't been touched in your analysis window. This lets you confidently trim the fat from those policies without breaking your applications.
getting you so much closer to that perfect state of least privilege.
So far, we've been a bit reactive, right? Finding problems that already exist. But this next part is where things get really powerful, because Access Analyzer helps you shift gears and become proactive, building security in from the very beginning.
Honestly, this feature is a total game changer. Instead of just guessing what permissions a new application might need, you can just let it run for a while. Then you ask Access Analyzer to look at all of its activity in your CloudTrail logs, and bam, it will generate a perfectly tailored, least privilege policy that contains only the permissions that application actually used. No more, no less.
And the process itself is just so straightforward. You pick a date range, it generates the policy, you give it a quick review, maybe tweak a thing or two, and then you attach it. This completely takes the guesswork out of writing secure IAM policies. It's amazing.
And on top of all that, it also acts like a spell checker for your IAM policies before you even hit save. As you're writing a policy, it's running over 100 checks in real time, flagging everything from simple syntax errors to major security risks, like using wildcards in dangerous ways. This helps you stop misconfigurations before they ever see the light of day. And finally, a great tool never works in a silo, right? Access Analyzer is designed to plug right into your bigger security operations and your automation workflows. It's a team player.
Every single finding it generates gets published as an event to Amazon EventBridge. Now, why is that a big deal? Because that's the key to automation. You can set up rules so that when a high-risk finding about an S3 bucket pops up, it automatically sends an alert to Slack, creates a ticket in Jira, and could even trigger a Lambda function to lock that bucket down immediately.
It also integrates perfectly with AWS Security Hub. This means its findings don't just live on their own little island. Nope, they show up right alongside alerts from GuardDuty, from Inspector, and from your other security services. This gives your security team that single pane of glass they need to see and manage your entire AWS security posture.
So let's wrap it all up. At the end of the day, IAM Access Analyzer is your automated detective. It helps you find and fix that risky external access. It helps you clean up all the unused permissions on the inside. It proactively helps you build secure policies from day one, and it lets you automate your entire security monitoring and response.
You know, the modern cloud is dynamic. It's always changing, always growing, and the only way to really secure it effectively is with tools that are just as dynamic and continuous. So that leaves us with a pretty critical question to think about. As your environment keeps expanding, are your security practices evolving right along with it, or are they still stuck in the old world of manual, once-in-a-while checks?